All right. So normally when we do this problem, we would just add the expected values together. And then we would do our formula for adding standard deviations, but remember they are giving you the variance. So you would do the square root of 6 plus 8 because they're already squared. However, there's one thing that they left out of this problem, and that is that these two random variables are independent. So the only way you can do this is if you have two random variables that are independent. And usually the problem states assume that they are independent. But this one did not, and so the answer is E. All right, number 17. So just the definition of bias, systematic error in a sampling method that leads to an unrepresentative sample. So again, it's an error in the sampling method, and we talked about a bunch of types of bias. Prejudice was not one of them, more like non-response bias, under coverage, those types of things. All right, number 18. So first it says it's bimodal. So bimodal looks more like that. This one's unimodal. And then it gives us a median right here. And so I estimated the height. So if this is 1, then each of these are 2. And I just kind of estimated these would be 5. So the total of those add to 17. That means that if I did the median, it'd be in the 9th spot, and there'd be 8 numbers on either side to add to 17. And so if you count over 1, 2, 3, 4, 5, 6, 7, 8, and 9th spot would be right here, which means our median is 9. And so it is not 7.5. All right, so that also takes out this one for the 5-number summary. It has the median also as 7.5. And then it says the mean is less than the median. So how do I know the mean is less than the median? Well, this graph is skewed what? I'm going to assume you guys said left. And so the mean is actually pulled towards the tail. And so that would make it C. All right, so we're comparing the Z to the T. So I just have a graph here. Remember that the Z distribution has less area in the tails and goes taller, and this T distribution has more area in the tails and doesn't go quite as tall. Both are symmetric, true. Both are bell-shaped, true. Both have a center of 0, true. Both have a standard deviation of 1, no. Look at these spreads. So that's the one thing that's different. The T distribution has a smaller spread than the Z distribution. So the correct answer here is D. All right, so first I would do a tree diagram, and remember that tree diagrams are always based on a conditional probability. So given the probability of 65% that interest rates will jump this year, and a probability of 72% that if interest rates jump, the stock market will decline. So this statement here is conditional based on the first. That's how we know we can do a tree diagram. So I have 65% that jump and 35% don't. So then if it jumps, there's a 72% decline. So what is the probability that the interest rates will jump and the stock market will decline? So and just means we multiply those two probabilities together. So it is B. All right, sampling error. This one is actually E. It's tempting to put B on this one, the standard deviation of a sample statistic. So the standard deviation of a sample statistic is this for means and this for proportions. However, we often don't know this, and so we use S sub x, and we often don't know the true p, so we use a p hat. That's what this is talking about, the difference between a population parameter, that's the true standard deviation or the true p, and an estimate of that parameter. So this is an estimate of this based on the sample, and the p hat is an estimate of the true p based on the sample. So it is E. All right, 22. The main thing is that you want to draw these normal curves because it says if 70% of the trucks weigh more than 12,000 pounds, that means that 70% is to the right of that 12,000. because 70% weigh more than this amount. And so the 30% is what you're going to use on your inverse norm. And then same here, we've got 80% weigh more than 10,000. So here we have 80% that weigh more than 10,000. So the 20% is what you want to use on your inverse norm. And then you could just do guess and check right here. So 30%, and you'd try this mean and this standard deviation and this mean and this standard deviation until you got about 12,000. And then 20% check it with the same numbers and make sure you get about 10,000. So the answer is C. All right, so this is talking about the percent of variation in Y is explained by variation in X. So this was the sentence for R squared you needed to memorize. So if they give you R, we can just square both sides, and that gives you D, 61%. All right, consider the following scatter plot. So it's not very correlated, but it does kind of have this downward tilt. And so it is B. It is not, so A would be a lot more linear. 0 is kind of tempting, but it does have some kind of negative slope happening. All right, so number 25, the center of the interval would have been 24%. You guys, this is the true P that they're giving you. It says the actual percentage of the public who watched the game was 24%. When you take a bunch of confidence intervals, they always contain a sample P. They may or may not contain the true proportion, right? So that's not true. The interval would have contained 24%. Same thing, even if you're doing a 99% confidence interval, it may or may not contain the true P. Remember that 1% of the time, it does not contain the true P. So none of these are true, and the answer is E. Okay, number 26 is E. So you guys, we never can eliminate sampling error. They just vary from sample to sample. For this one, we don't influence responses. Same thing here. Treatments are carefully planned to result in responses that are similar. No, we aren't trying to influence the responses. And then double blinding is a useful matched pairs design. That's not a true statement. Matched pairs is actually a type of blocking design, but those don't go together. So the answer is E. Okay, 27, there's really no correlation, so the answer is E. '28, the answer is A. So we want to put 2.8 here in the middle and kind of draw a graph would help. So we want to know if they get less than 2.5 pounds. Assume the standard deviation is 1.2. So they all have the same formula in the denominator. And then if the true mean value is 2.4, so we actually want to use that as our second number. So remember just kind of a general formula here for Z. We always are subtracting the true mean if we know the true mean. Otherwise, we use the one from the null hypothesis. But for this one, we actually know the true mean is 2.8. So I want to know how far away we are. And then it's just a matter of greater than or less than. So what's the probability the researcher will mistakenly fail to reject the author's false claim of 2.8 pounds? Well, if we fail to reject, that would be greater than. We got greater than when we should have gotten less than. And so the answer is A. Okay, which of the following is the central limit theorem? So first of all, you guys, the central limit theorem is basically if the population is not normal for means, as long as we have large counts, which happens to be greater than or equal to 30, then we're good to go. So this first one is talking about the mean of the sample, so a bunch of little x bars equals the true mean. That is a true statement, but it is not the CLT. And this is kind of the same thing, but with the standard deviation. So talking about all the little x bars, your standard deviation is sigma over the square root of n. Also a true statement, but it is not the CLT. Okay, this one, if the population's normally distributed, then as the sample size increases, then it gets closer to normal. So you guys, if the population's normal, you know, no matter what the sample size is, that the sampling distribution is normal. So the only time you need the CLT is when the population's not normal. You have to have large counts. All right, so the correct answer is E on number 29. Okay, what is a sampling distribution? It's every possible way you could take a group of a simple random sample of size whatever from the population. So for this one, a distribution of all the values taken by a statistic from all possible samples of a given size. There you go, D. So first we need to make a back-to-back stem plot for this one. So it looks like this. Remember that even if you don't have any leaves, you don't skip any of the stems. So you want to go from 3 to 9. And on the right, they're going to go this direction, least to greatest. And on the left, make sure they're going this direction, least to greatest. Okay. And if you make a good stem and leaf, you can answer these questions pretty effectively. So for this one, what about the distributions is missed when you're just talking about them having the same median? So they do have the same median. However, notice these numbers are all a lot closer to 65, which is the median, and this one's the median here, but we've actually got like a bimodal distribution, and so there's a lot of numbers further from the median, whereas this one has a lot more numbers close to the median. So while the percentages in both regions have roughly symmetric distributions, the percentages from region A are unimodal, while region B is bimodal. This means region A had more percentages near the median, while region B had more further from the median. All right, part C. So who should we help as far as with their education funds? Which group needs more help? So you can actually argue this two ways. The first way, you could say that region A needs more help because there are more values that are higher in region B, and that way we could bring some of these people up. But you could also argue it the other way, and you could say region B because region B has a lot more countries with lower percentages of students who are going to school. Okay, and D is kind of tricky. So basically, if we wanted to do a two-sample t-test, we would have to check random and 10% and large counts. And actually, the first problem is random. So they actually took 17 countries of two geographical regions, and they took all 17 countries. So they never talked about taking a simple random sample. And so you can't run any kind of confidence interval or test unless you're taking a simple random sample. So data are already given on all countries in the two regions. When doing inference, one uses sample statistics when estimating population parameters. So they did not take a simple random sample, so you cannot do a two-sample t-test.